Good morning, this is Keith Bryant on the Keith Bryant Show at day 2 of Apex, and I'm joined by Teresa and David from the IPC, and we're going to talk about an exciting project, the results of which have been 5 years in the making. It's unusual for standards and stuff that this is actually very interesting, and I would say even after the 5 years it's still really topical and on the button. So I'm going to ask Teresa first to tell us how it all started.
Sure, thank you, Keith. About 5 years ago, as you said, the task group had a question come to them concerning conformal coding, and they realized that, hey, this isn't an easy answer. We can't answer this in a few minutes or even a few days. So we looked around the room and we thought, we need a volunteer to lead this effort, and there sat Dave Hillman. And we said, hey, will you take a look at this question and research it for us? And he said yes, and he started his project.
And I probably should have been paying more attention in committee than what I was, so I got volunteered for something which, as it turns out, is one of the better things I've done in my career. So,
well, it's a very long career, so that says a lot.
As Teresa said, the basic question was revolved around conformal coding and coverage and thickness. And to answer that question, to do it right, you needed a baseline. Well, we quickly understood and realized no one had ever baselined the electronics industry on its 5 types of primary conformal codes. And we thought, how are we going to do this? And Keith, you've been part of those state of the industry assessments. And they only work if the committee is very honest with itself, because you always see those people, these coupons, they're going to committee. They should look very pretty. And that always ruins that kind of thing. But this was very exciting. We had 12 volunteer companies. We had 22 co-ops that were on the project for over 5 years, measuring conformal code through cross-sectional methods. A really neat teaming example of how the conformal code suppliers and the users came together to set a baseline that is very honest, very straightforward. And at this point now, industry-wise, if you're doing tin whisker research, you can use this to understand how would I improve my conformal coding methodology. If you're in harsh environments, what do I do with corrosion? So the interaction and collaboration is really exciting.
Yeah, I know exactly what you mean about this, because I did something similar a long time ago and got samples from a company, and they were really excellent. And they said, well, they should be. We coded them 3 times. The first question that springs into my head about this is, you have 5 primary coding types, and the perfect coding thickness for them is different.
Correct.
Especially if I guess you threw parylene into the mix as well.
Absolutely, we did this, the standard 5.
Yeah, and that's a beautiful coating, and it's you're talking microns, and then if you look at epoxy or you look at some of the UVs, you're talking almost millimeters. So when you did your baseline, did you decide what was optimal for each of the 5?
We didn't, because we approached it from the other side of the coin. We said, what is everyone doing? What if I went to a Hillman garage shop and I asked for acrylic, and if they sprayed it, what would it turn out? So when you look at our data set, there were over 100 test boards. There are 26 individual data sets that cover acrylic, epoxy, urethane, silicone, and parylene. They were put down by both manual spray, automated spray, and within automated spray, both the thick flow and the atomized. They also did brush, they did dip, and then we had allowed a couple exotics to slide in. But those were characterized in terms of their material and their application. We made it very blind. No one in the committee, outside my co-ops, understood who was submitting samples. And also, we didn't say, this belongs to Humaseal or this belongs to specialty coating. So it was a completely blind study. That's a positive, because now we don't want anyone judging good or bad. It's a baseline. It's a data set to allow people to do additional collaboration with their customers or with their suppliers. But on the other hand, it also means some of the very detailed things one might ask, one will never know. So it's 50-50, but it had never been tried. And it's where this is how IPC really brings power, collaborating those people for the betterment of the industry.
Yep. So Teresa, you'd say it's like if I couldn't pick a better word, I would say it's a true standard.
It certainly is. We're really excited to see this completed, and the benefit that it's going to bring, the value it's going to bring to the industry is phenomenal.
Yeah, it's, conformal coating almost went away. And now with the harsh environments, the automotive, the wonderful tin whiskers, and even the normal lead-free assembly, even what I would describe as the consumer guys are looking at needing to conformal coat. So it might have started 5 years ago, but it's ended at a time that it's really, really pertinent for pretty much every sector of the industry.
That's certainly correct, and I think what Dave didn't mention is when you were giving the numbers is we started out with a small group of people working the action item, but we would have regular updates at meetings such as Apex and our fall committee meetings, and we saw this committee roster grow with the number of people interested in the data. And the data was presented, interim reports were presented to that task group all along. So it was really exciting to see it grow to the final set of 26.
We started out with Excel spreadsheet results Rev A, and we finished with Rev AD. And the Excel spreadsheet is so big that if you make a mistake, the instructions are don't save the copy, throw it away, and start over, because you can never find your mistake. It is probably a 10,000 line analysis pivot table Excel spreadsheet. One of the biggest ones I've ever seen put together. Beautiful mapping by our statistical engineers to pull that data together.
Yeah, that sounds like okay. First of all, a lot of work to gather the information, but in the way that you're handling it's a huge amount of processing and everything else to come to the conclusions. So, yeah, that's an amazing study. And when is it going to be put out to the world?
We have a few more things to do to finish it off, and I would anticipate second quarter we will see it out out for the industry.
Okay, then I guess my last question is, please tell us what the number is going to be.
587.
Excellent. IPC TR 587.
Okay. I just have one last question, David, because we chatted about this a little bit before. Can you explain the pirates?
So it seems to be a trend with all the little sub-task groups that come out of the committees. They all need a nickname. And, of course, this task group started out as 521 ARR. So 521R.
Yeah, I guess I shouldn't really have asked that question, should I? Especially not of you.
You know better.
Yeah. I'm really impressed that you two guys have come in and chatted to me about this today, because, as I say, we all live with IPC and 610 and 7095 and all the standards that we know, and yeah, they get regularly updated. But it's very rarely, if I'm completely honest, I'm trying to remember the last one where something completely brand new and as relevant as this appeared not only from IPC but from anybody who's producing any kind of standards. So I think it, first of all, because it's been used by a lot of, I guess, not only the material manufacturers but the coating equipment manufacturers have already got involved. I think that the take-up is going to be really, really fast. And I guess you'll soon be starting to work on the next version.
There is talk that we should do a follow-on. I don't know how enthusiastic, will I be here in 5 years? That might be the bigger question. But, yeah, we're enthused. It's a lot of collaboration, a lot of teaming. It's going to enable a lot of discussions to ensue.
And in the meantime, he has other action items to complete.
I don't know what to say now.
I work for her. Yeah.
Yeah. No, in all seriousness, I hope that it comes out soon, because it's one of those things, the sooner the better. We have a harsh environments conference that I'm going to in April, and we went to it last year, and conformal coating was the biggest question that everybody was asking, not only overall thickness, but which material should I use, and how do I cope with the fact that every time there's a corner of a component, it gets thinner. And I guess you guys, at least if you're setting a good baseline, then, people can look at it, and if they have, specifically difficult components or different areas of the board, then they can tweak what they're doing. But once you've got a baseline, you've got something always that you can work from. So No, it's really exciting.
See, you haven't even seen the report, and you know exactly how we hope people will use it.
Yeah, well, we're only engineers. It's not rocket science.
True.
All right. Thank you both very much for coming in and sharing your time with us. And I look forward to the first edition. Hi, this is Keith Bryant, and we have day 2 of the Keith Bryant Show at Apex 2019. And I'm joined by 2 of my good friends from Mirtec, Brian D'Amico, who is President of North America, and David Bennett, who's President of Europe. And I know we've just seen a press release that you guys are having another record year on top of a record year. So perhaps you could give us a bit of the detail between the headline, "Everything is great" number.
Everything is great. Just read the headline. Now, we actually had the most successful year we had in our corporate history, which is a big achievement here. Mirtec Corp, North America, we did extremely well, beyond all expectations. Now, we did have a lot of new technology that we offer that I believe is driving the sales forward, and that's with the automatic programming software that we introduced. It's driving sales. But quite frankly, it has been the best year. We've had growth ever since, I think it was 2009 when we took that big dip. Right. Beyond that, we've had growth steady every single year. So we've had 8 consecutive years of growth, with last year being our best year. January of this year so far, we've already booked $2 million worth of orders, which I've never done, ever. So in a nutshell, that's it.
So that's good. Are you seeing the same in Europe, David?
Yes, we've had a similar thing, Keith. We've had very similar to Brian. We started in 2008, 8 and 9, small numbers, making some money, but small numbers. And then it just exponentially grew. Last year was our best year by far, and the year before was pretty good as well. So it was a real bumper. The result of 2018 was a credit to my team and also to my distributors, and of course a big thanks to the customer.
Okay, this is going to be difficult because this is a 2-part question. Okay, the first part, is the market growing or is it your market share? And second part is, are you seeing the change from 2D to 3D being the biggest contributor to the success?
Right. As far as the European market, and when I say Europe, we look after India, South Africa, Middle East, so it's pretty encompassing area. It's virtually all 3D. I mean, probably I'm going to say in the high 80s at least. So yes, it's technologically driven. It's very demanding. I think the European market is probably recognized as the most technical market in the world. It doesn't have the volume of some other areas, but the work that's being done there is always right on the edge. So they want whatever's the best. You know, they don't care about price as much. I mean, everybody cares about price, of course, but what I get asked more than anything else is to come and look at the issue, look at the problems. What have you got that can help me here? And it's very demanding, so it really suits the Mirtec product.
Yeah, I mean that's what we're seeing generally is happening in Europe. It's all about increasing yields, reducing costs, and doing everything they can. So I guess you're seeing a lot of 2D equipment being replaced by 3D, and then you're seeing a lot of people putting SPI in to get increased yields as well.
Yes, very much. I certainly wouldn't think it's the end of 2D, because when Industry 4.0 starts to be deployed properly, you can't have a gap in the middle of your line. So there will have to be a technology after the placement systems. Now I know you can use 3D there, but I believe the vast majority, when they realize that you can't have a dumb area in a production line, will invest in 2D.
Yeah.
So,
I mean, 2D in that position makes more sense because you just want to see if the component's there, if it's in the right place, and it's the right component, and it's the right orientation. And you guys can do that dead easily with 2D.
yeah, definitely. So I think it's going to have a resurgence,
Yeah.
but for a very specialized usage.
Yeah. And are you seeing the same thing, Brian? Is it driven by technology, or is it driven by people getting into AOI for the first time, or basically, what are you seeing that's your biggest contributor to the sales success?
All right, see, I'm seeing the growth where my customers are basically growing and adding more lines of equipment, which is great. So I think that the industry overall is growing. And I'm hearing from quite a few people who are doing well, doing much better than they had done in the past. Other vendors of SMT inspection equipment, and also pick and place, screen printers, etc. So I believe the industry is growing. I also know that, of course, people are investing in that new technology in 3D. One of the things I think is going to happen is kind of go along with what Dave is saying. People who've invested in 2D technology already, if they're really looking ahead to Industry 4.0, the goal there would be to take the 2D systems that they have from the past, now put those in the middle of the line, put them post-placement, and then invest in that 3D system for post-reflow. And I am seeing that a lot of people are investing in the new technology. What that does, it frees up a lot of 2D systems. There's seems to be more 2D systems on the market, but they're used machines. The smart customers, I believe, are taking those 2D systems and using them for post-placement and investing in that whole Industry 4.0 in the future, because you need the information. Of course, wherever you find the defect, if you can find a defect post-print, right, of course with your SPI, you clean off the board. It's really easy, right? If you find it post-placement, you take out your tweezers, you either put a component down that may be missing or change the rotation. The cost of fixing the problem is much more inexpensive the quicker you find it. So it makes sense to have that 2D system post-placement.
Yeah, and the biggest one that we're seeing when people are doing that, the thing that they catch is somebody who's loaded either the wrong reel, or they've loaded the wrong value of a resistor or whatever, or the pick and place machine has just got a blocked nozzle or something, and it's just dumping the components on the board instead of putting them where it's supposed to put them. And those things, they don't sound much, but once you've got past reflow, you find them in in-circuit tests to begin with, and that's $150, $200 a pop to begin with, and it really is a saving.
Yep, exactly.
Yeah, I mean, if you look at all of the different, I'll call it offerings coming from everybody, we've got about 6 standards in this industry so far being acclaimed. I don't know how you can have 6 standards of something, but that's how it seems to be. Eventually there will be a system standard, a usage that will be acceptable to the customers, and we will see somebody really go big time, maybe across a multinational, starting to deploy their lines with his high-tech feedback, we'll call it Industry 4.0, as possible. And I think when that happens, their competitors, the other EMSs or whoever it is, have very quickly got to deploy, very quickly. And for me, I've always said the same thing. It's got to be badge blind, because there's going to be legacy equipment, there's going to be new equipment. I don't think you can go in and tell people what they're going to have.
Yeah.
I think it's a case of we can connect to anything. You can, even other competitors maybe.
Yeah. Oh yeah. I mean, I had David Bergman from IPC sitting here yesterday, and the thing that excited me was he said, okay, we've got all the connectivity, we've got CFX running now. Our next goal for this year is connecting legacy equipment.
Yeah.
And that, as you say, that's really going to be the big thing that's going to make 4.0 take off.
Yeah.
I mean, we know that it works as a technology. We've looked at lines that have, let's say, a 95% first-time pass rate in circuit test. By putting in some better metrics and some better controls, we can save 4.5%. So their first pass yield goes up to 99.5. And if you put that into monetary terms for a single production line, it pays for 4.0, it pays for whatever you need to connect the machines, and it starts making a profit after a couple of weeks. And it's gonna give, as you say, the contract manufacturers a huge competitive edge, because it's all about yield, it's all about profit, and it's all about running everything as tight as you can. And yeah, it's definitely going to make a big difference. And you guys are there at the forefront, and your Intellisys platform is already doing this stuff for inspection already. So, it's good to see. One last question before we talk a bit more about technology, and it's personal interest question. You're doing.
I'm sorry, we don't take those questions.
Oh, okay. I was going to say you're doing incredibly well. We know this. Your figures prove it. How does that translate globally to numbers of machines that you've got out there running?
Well, we've actually just sold our 17,000th system. So 17,000 machines out there that Mirtec. We've been in business since 1999. It's quite a few machines. So we're going to break open some champagne a little bit later, and you're invited.
Okay, I'll just have a small glass because I know that's all I'm going to get offered anyway. Okay, technology. Obviously, things are getting smaller. Things need to be done faster. 3D AOI is a very competitive environment. How are you guys holding together the technology advantage to make sure that you keep the sales increase going?
That's always a good question. Of course, there's always good competitors out there, and if there weren't, then our machines wouldn't get better, right? And their machines wouldn't get better either. It's always a matter of leapfrogging one another, right? The key with Mirtec is we've always had the most advanced technology out there. We really do concentrate heavily on technology. So with, of course, our camera system, our 15 megapixel camera, there's still nobody out there that has a 15 megapixel camera system. It's important to have that heart of that system being the best that it can be, right? The 15 meg camera allows us to achieve speed. It allows us to achieve accuracy. That's the core of the system. Beyond that, we have projection technology for 3D. So the technology that we're using there is Blue DLP Moire. Blue DLP Moire can deal with reflective devices. And also what we're doing is we're able to now look at, using 3 different frequencies, we're able to look at devices from 0 to 25 millimeters tall. All of these advances that we've made with our systems are what we've done to try to achieve, once again, that leapfrog over our competitors.
Okay, so I understand the issues that Moray always has with the reflective components, which, I mean, that was the big issue from the early days of the fixed grid Moray, like the comb. So it's good that you've got around that one. And yeah, I understand the more megapixels you have, the bigger the image, but normally the longer that takes to process. But how does that affect the field of view? Because field of view is the speed thing. If you could zap a whole board in one image and then do all your processing, you're going to be a hell of a lot faster. And if you've got a lot of megapixels but only a small field of view, you're still going to have a huge amount of processing because you've got lots and lots and lots and lots and lots of images, and you're going to have tremendous image quality, but you've got a lot of processing and a lot of time.
Yeah, it really depends upon the features that you're looking for. For normal SMT production, you're talking, and it's all gated by the telecentric lens that we use. It's gated by the resolution, right? So if we have a 10 micron system versus a 15 micron system, of course the 15 micron system is going to have a larger FOV. So there that translates to speed, right? If you have a 10 micron system, you're kind of gating down or decreasing that FOV, but you have more accuracy. If you start getting at the semiconductor stuff, you're talking about, sub-micron level. Of course, you're dealing with very, very small FOVs. So it really depends on the customer's application. But of course, if you do decrease the FOV, it's going to end up taking a longer time because you have multiple, you're still dealing with 15 megapixels of information, but it takes more frames in order to process the board.
And are you seeing that being an advantage in Europe as well, Dave?
Yeah, as I mentioned earlier, Keith, whatever Mirtec does, it tends to drop in the European market first. Every bit of press, every technology leap we do forward, there's always a European customer somewhere, whether it be the UK, Germany, France, Italy, Spain, who are doing something that's quite complex and see the advantage. Because we don't just make this stuff up for fun. We do it because we know those issues need to be solved. So the guys at Mirtec are they knew there was a reflective issue with Moray, so we create the blue Moray. We knew that the camera industry wasn't overexcited about trying to give us what we need as an AOI manufacturer when they can sell tens of thousands of cameras to a factory looking at beans, So it's crazy that as a inspection company, an optical inspection company, that we did not have control. So many years ago we made the decision, we will develop, we will manufacture what is needed to go forward. And from that now, it's become sensors, lighting, everything. With the Mirtec, nobody except Mirtec controls where we go, when we go, how we go. Every other company, almost, I've got to say, all of them are in the hands of their suppliers, and they can stop the camera, they can do whatever. And I don't care how big the AOI company is, compared to 100 food factories around the world or medical factories, the volume of camera that we would be buying is negligible to them.
Yeah, and you have exactly the same issue that we've always had with electronics X-ray. You're a very small customer, and you have to rely. I mean, in our case, traditionally it was the medical industry, because they're selling millions of X-ray machines, so they're making loads and loads of parts, and we're buying in the thousands. So yeah, it's good to know that other people are suffering the same pain. But you guys have found a very novel way around it. But of course that the control gives you a cost.
Yes.
But it's obviously been worth it to give yourselves that sort of unique place at the front of the market.
It was a brave move. When we went into this, it wasn't a 5-minute fix. It took years to actually have a camera system that we can proudly stand up now and say there is nothing in the world that competes with a 15 mega co-express high-speed camera. And we've gone beyond that. We've got 25 megapixel, we've got 18 megapixels, we've got all different types of cameras and lenses depending on what is required, whether it's LED manufacturing, whether it's semicon, whether it's SNT. We totally control, as I say, what we do, when we do, where we do. And I think that is by far our biggest strength. Our customers never have to worry that when some technology comes in the future, that their supplier is going to be looking on the shelf of some camera company who's designed a camera to do something, a little bit of something for a lot of people. If they look at a Mirtec, they'll be looking at a camera that's designed specifically to deal with that problem. Because it's our industry. We know what's coming. We're already looking for the future.
Yeah. So yeah, market trends and customer feedback are always the best way to drive your R&D department.
Yeah, most definitely.
Well, gentlemen, thank you both very much for sharing
Keith.
your time, and I'll be round for the glass of champagne this afternoon.
Always a pleasure.